Good morning, guys. So today morning class would have been finished, and I hope you have completed the derivation for refraction at spherical surfaces, and you got some introduction in the part of lens, etc. Right now, we'll move on with the next topic which I have planned for today, which is lens makers formula. Right. So it's again a derivation, right? So I hope you have understood what and all are the parameters of a lens, right? And have taught or what is the property of convex mirror. Convex mirror is a converging lens. Convex lens is a converging lens, whereas concave lens is a diverging lens, right? That's my portion, right? That's not a big deal. So here we will be dealing with a lens from this point of view, right? Clear? Right. So before this no, the derivation, I would tell you the derivation which we are going to take is for a large type of or a thick type of lens, and the normal type of lens formula is for thin lens, right? So there are two types of equations, which is a modification of the bigger one lens itself, but the thin lens equation is something which we use in the daily life, or for majorly I would say in 10th class you have dealt with the thin lens formula actually. Okay, we'll deal with it. So for lens formula, curves formula, I'm going to draw a small, this is lens, right? Now this lens is actually, I have told you, is made up of two what spherical surfaces, right? So I can extend this one as one circle, and similarly this one is made up of another circle, right? Yeah. So this is just an imagination I have drawn for you guys to understand. Now this lens, let's say, let's remove the circle, is such that it is kept in air. So first of all the derivation we are going to deal with when it is in air. So let's find, or usually this medium which in which that is length is kept is air. Now let's say if it is a medium, I have to write it is having a refractive index nm. Now let's say nl is the refractive index of the mirror, right? Now I told you this one section, this one is a part of a sphere or a spherical mirror, right? Spherical surface. So it would have what which is known as a radius of curvature, right? Let's say this is the radius of curvature of this one. This one is the first one. Let's say that is, or if you want you can make this a second, because usually the incident rays comes like this, right? Let's change it. Sorry, because we'll draw it with another color. Okay, let's say this is the extended version of this surface, right? Now let's say all the incident rays are coming from here, so this becomes the first surface and this becomes the second surface. Yeah, the ray which is falling on the surface, that surface becomes the first surface and the other one becomes the second surface. Common, easy to understand, right? Now let's say this first surface is having radius of curvature r1, and this surface is having radius of curvature r2. Clear? So this surface is having r1 radius of curvature, this one is having r2 radius of curvature. This and all are known. I took this one as r1 because I am taking this incident rays, right? If the incident rays are coming from here, then this becomes the r1 surface. Just keep that in mind, right? Clear? Now we are going for the derivation, right? So let's take a thin lens. This and all parameters, I hope you understood how to take r1 and r2. This is the lens, right? Let's say this is the axis, this is the what optical center, right? Let's say this surface becomes the first surface, right? So let's say its center of curvature, this one, right? So its center will be here. that center of curvature, let's name it as C1, right? Let's rub it. Similarly for this surface, this one, right? So there will be a radius of curvature, let's say C2 here, right? So that I hope you understood, this one is having radius of R1 and this is having radius R2. So this one's center of curvature is C1 and this one's center of curvature is C2. Clear? Right, I hope you understood C1 and C2. Right. Now let's say, suppose we are going to keep an object beyond the C2. Suppose this is the object. So the incident rays will come from here. Right. Let's say it falls over here. Right. So this is usually rarer medium, that is air. Right. And the mirror or the lens section is the denser medium. Right. Again, this becomes a rarer medium. Right. And what was the refractive index? It was Nm, and here it is Nl for our lens. Right. Now, see, for any spherical surface, spherical surface like this, right? Any spherical surface, the normal is something which passes through the center. All the normals. See, if I draw a normal here, it will pass through the center. And normal, if it is drawn like this, so all the normals will pass through center. Keep that in mind. So here also, see, this surface is a part of a sphere which is having center here. So how will I draw a normal for this point? I am supposed to draw it like this. You are supposed to look at like a straight line. Don't know why it didn't come up a straight line. This much clear. This is our normal for this one, for the first surface, right? So this incident ray is moving from rarer to denser, means it moved towards the normal, right? So if this face was not there, that is, this mirror was not there, it would have moved like this, right? So that has to be deviated and has to move towards the normal. Let's say it is bent like this, right? And I'm extending that point to this point. Let's say this is the image formed, right? Clear? So this is the image, let's say I dash is the image of which surface? Of the first surface, guys. Clear? Right. I'm drawing it above because you guys can understand it, right? Clear? Now, but if this is image is not the actual image, because you are not having one surface, you are having how many surfaces? You are having two surfaces, right? So as there is now, the ray are moving from glass to air now, right? Because when it reaches this surface, the ray has bent now and it has reached this point, right? Let's take a red dot, then you will understand this point has been achieved. Right, at this point, the medium changes there, right? That is from denser to rarer medium, right? So again, I have to draw a normal for this surface. This will be the center, right? So the normal will be like this, right? So this is the normal. So again, how should the rays bend? It should bend away from the normal, right? Clear? So this is the normal means, right? This was the way it was supposed to move, in this way, right? Because of this surface, this I dash is not formed. Actually, it is formed, right? So in place of I dash, or let's say, I will redraw it, right? In place of I dash image, due to this surface, and moving from denser to rarer medium, moving away from normal, cause the beam to bend, let's say here. So that this I image which I have formed is due to both the surface. First due to this one, then it bent and went to this surface one, right? Second surface, again it was moving from denser to rarer medium, moving away from normal, right? This is the normal, it moved away from normal like this, and it reached the point here, and I mark that image as I. Now what I see is the image. I am not actually seeing I dash, but actually there is the image I dash, because we have told before, when two lenses or two mirrors are acting, right? When remember we did a lot of problems, right? If this mirror is the first one and if it is having incident rays, then it will form an image. That image acts as an object for the second mirror. Remember we have taught the same thing is happening here in the case of lens. Two reflecting surfaces are there, right? So image of the first reflecting surface acts as the what, or spherical surface acts as the object for the second face. Clear? If you want, I can depict it pictorially. This one is the first face or surface. It produced an image I dash, right? That I dash becomes the object for the second one, so that it produces a new image just before the I dash, which is I. Clear? Hey, now the derivation is not completed, right? The derivation is still pending. This much clear? Right. So in the above diagram, some of the parameters are very important to be marked, right? How would I mark it? So this is the object distance, right? This is the object distance. Let's mark it as U, right? Right. Now this object, when I kept for this surface, first surface, where was the image formed? I dash. So for the first surface, the image V dash is here, distance from here to here. This is for first surface. Clear? But when this I dash, right, acted as an object for the second surface, this was the image formed from O to I. This one. This is our actual image distance, which is V. Clear? Right? That is the actual end image distance. So this is the actual object distance, right? And due to the first surface, an image was formed, which is I dash. Its image distance is V dash, right? And this I dash image acts as an object for the second reflecting surface, which caused the end image I, which is at a distance V from the optical center. Hence it is V is the end last image for the entire lens as well as for the second part of the spherical surface. Clear? Now this much is clear, right? So this and all parameter we require. Now, so I hope you are marked or understood the markings, right? Now we are going for equation of optical surface. What we have written, N2 by V minus N1 by U is equal to N2 minus N1 by R. This was the derivation we did, where N2, what is the N2? N2 is the refractive index of the medium where the light goes in, right? Into which the medium, suppose this is the light coming into water, then water is the having the refractive index N2, right? Because the light ray is coming into it, right? And from where it is coming? Air, right? So air becomes N1. So that means N1 is the refractive index of that medium from where the light comes out. Clear? V and U, I hope you understood the parameter. This much clear? Now let's deal with the first surface. Right? First surface. So in the first surface, this one. Right? The light ray is coming from where? From air to this medium, right? So, and to which medium? Into glass, right? So N2 becomes into what? This is NL and this is NM. So it is light rays coming into our glass. So N2 becomes NL, that is the lens refractive index divided by the first refracting or the curved surface or a spherical surface causes the image at V dash, right? So it is V dash minus from where the light is coming, from the air, hence it is from medium, I can say, divided by U is equal to N2 minus N, that is NL minus NM. And for which surface I am going to take? First surface, hence its refractive index, that is R1. Clear? Right? Keep that. We will write it as first equation. Right? Now similarly, we are going to write for the second surface. Right? This was a second surface. So the light was coming like this. Of course it is bending, but just making sure that you understand the light is coming from glass to medium. right? So the glass is where the light is originating and it is going into medium, right? So nm, right? N2 becomes nm divided by what is the image distance of the second surface? It is here, that is I, which is we mark it as v, that is oi is v, that is actual image, right? That is nl, right? Minus nl. And what should I write for object distance? I just told you the image of the first medium became the what object for the second surface. So the first surface's image distance becomes the object distance for the second surface. Hence I will write it as v dash is equal to nm minus nl by r2. That is for the second surface. Clear? Right. Now we are going to do what? We are going to add them. So nm, it is common for this guy, right? Nm, sorry, some images are popping up, right? Nm by v minus u. Why? Nm is common for here and there is u common, right? Is equal to nl minus nm, right? 1 by r1 minus r2. Check whether it is true or not by looking at the what you have written in the notebook. Okay, this is just maths. So I'm going to bring nm here downwards, so it becomes 1 by v minus 1 by u is equal to nl minus nm by nm 1 by r1 plus 1, sorry, minus 1 by r2, right? Now I'm going to give nm to each individual. So it becomes 1 by v minus 1 by u is equal to nl by nm minus 1 by r1 minus 1 by r2. Clear? Now what the equation which you have written here is actually a short form of, it is not yet reached, but I am just telling you this is the what breaking point for Lens-Baker's formula, right? Now next section, suppose this is our convex mirror, sorry, I'm just telling mirror again and again, this lens. So light is coming from infinity, it will meet at focus, right? Right. So when object distance is infinity, the image it is f, right? So this same section I am going to write. So what will be 1 by v minus 1 by u? In place of v, I am going to write it as f, and 1 by u is 1 by infinity, which is 0, right? So this term goes off. So in place of 1 by v minus 1 by u, I can write 1 by f, right? Clear? So here I will write 1 by f is equal to nl by nm minus 1 divided or into 1 by r1 minus 1 by r2. This equation which you got is called Lens-Maker's formula, right? And which you just made sure of a small equation, that is 1 by f is equal to 1 by v minus 1 by u. This is the lens equation for thin lens, which you have learned in lower class, right? This equation is actually for only thin lens. Clear? Right? Right, and I told you what and all are the parameters while you're doing this calculation. R1 or R1, which is the surface we always take. The surface from where the incident ray comes or where the incident ray falls is known as the first surface, and that its refractive index is, sorry, that's radius of curvature is taken as R1. Right, and all of the time the signs should be taken. All the rays which are in the incident ray direction is positive. All the directions are measured from what pole? Sorry, optic. I don't know why I'm repeating the parameters of mirror lens, optical center, right? Clear? And a small key point for you guys is, suppose you can keep this in mind, focus of a convex lens which is converging in nature is positive, whereas focus of a concave lens which is diverging in nature is having negative value. Keep that in mind, right? The next theory section which we are going to take is magnification of lens. My dog is barking like anything. I don't know why. Bear with me. Right. So magnification of lenses, again you have to derive the equation. So usually we consider a biconvex lens which is very thin in nature. The line is not straight. That's okay. I hope you understood. Suppose this is our object A and B. right? This is the incident ray, right? And this is the optical center. One ray is passing through the optical center, and this one diverges this, right? And this is the focus, let's say, right? This converge, right? Converging section. Let's let it meet, guys. I am going to meet it like here. I hope you understood, right? So the image is this one, right? This is B dash, this is A dash, right? Now this distance from optical center from A dash, this is our image distance V, right? This is the object distance, that is U. Let's say this angle is theta, then this angle also will be theta, right? I hope you understood the parameters. Now let us take the triangle OAB and triangle A dash B dash O. Clear? OAB. I'm going to take another color to make you guys understand. This is OAB, right? Right? And what is the O dash B dash, O A dash B dash triangle? This one. There is only two triangles which you can see. This one. Clear? Now these two triangles are similar. How? They are having common angles theta, theta, and this angle is 90 degrees. So these two triangles are similar, right? That means I can say the ratio of their sides, right, are equal. So I can write A dash B dash by AB is equal to D or OB, right? It's OB, now OB dash by OB, right? I'm so sorry, guys. I don't know why the dog is barking like anything. Now A dash B dash is in negative direction, right? So I will write A dash B dash as what? Image height, but in negative value. And AB is the height, right? That is height of the object, which is in positive direction, right? Now OB dash, that is our, right? OB dash, this is the incident ray direction, so this direction is positive. So V is measured from here to here, right? So it is positive, whereas U is measured from in this direction, right? So U is negative because it is opposite to the direction of incident ray. So I will write V by minus U. That is HI by HO is equal to V by U, and ratio of height of image by object height is known as magnification. So magnification of a lens is V by U, right? Now keep some of the things in your mind, guys. Now if if we see it is positive, that means when a object was like this, the image was like this. Keep that in mind. That is, it was upright, erect, and it was virtual, right? Now second condition, if M is negative, that means if the object was like this, the image was like this, right? That means it was inverted and real. Keep that in. These are all small pointers, guys. It will help you in solving problems. It is inverted and real. Clear? Just looking at the magnification value, you can just get an idea of how the image will look like. Clear? Right. That similarly, convex lens, right, the magnification can be either positive or negative, however it can go. But for concave lens, right, the M will be definitely always positive. Keep that in mind, right? समझ में आया? Now let us move on with the numerical sections, right? Now you are given a biconvex lens. That is the first question, guys. And let's say that lens first surface, this one, let's say this one, is R1 is equal to, and this surface radius of curvature R2, this is R1. Both of them are equal. R2 is equal to 10 centimeter. Let's say like that question. And let's say the refractive index of the glass or the lens is 3/2, right, in air, right? Now you are asked what is the focal length of the what, or where can you find the focus of this lens, right? Guys, some of the time I always forget that I am going to deal, or I am dealing with lens, and I say mirror in that place. I'm extremely sorry for that. because I like mirror more than lens, obviously. Now, how would you deal it? So obviously you have to draw a lens like this, right? Now, okay, let's bring this one down. Now, this lens, let's say we are not given anything about how from where the light rays are coming. So I will take, let's say the light rays coming in this direction. So this direction is positive, keep that in mind, right? And this surface becomes our first surface, and this becomes our second surface. So this one's radius of, see, this surface, this one, first surface, C1 will be here. I'm going to write it again. This surface, the first surface radius, or sorry, the center of curvature will be here, let's say C1, so that this distance is what? R1. Keep that in mind. I'm going to remove it. Okay, now let's say this is the second surface, right, and its center of curvature from here, C2, right? So this distance will be R2. If you want, we can write here now. This is R1. Right? Clear? Right. Right. Now, let me tell you, R2 is in opposite direction as that of the what? Incident ray. So this is mine. So you guys keep in mind, in the figure you will see this much distance now. So you will say, obviously the distance has to be measured from optic center, so this much distance is lagging. No, this is very simple. The lens is so small that, right, this difference, suppose this is optic center, you are supposed to measure R1 or supposed to measure from here only, but I am telling you this is the surface, so this much lag is coming here, right? So this is a waste, right? But keep that in mind, something which I have told earlier itself, that is this lens is, or this lens, or usually the lens is very thin, so the, if you are measuring from one surface, is equivalent to measuring from the optic center itself, that much thin it is. Clear? So keep that in mind. So this is the direction of incident ray, which is the positive direction. So R2 will be minus negative, sorry, minus value, whereas R1 will be positive. Clear? Now, I've written the equation here earlier itself. So 1 by f is equal to, because this equation is required throughout. So what is the lens refractive index? 3 by 2, right? And medium is AR, right? The lens is kept in AR. Minus 1 by R1 is what? Plus 10, minus 1 by R2 is minus 10, right? So it becomes what? Now that is purely calculation. 3 by 2 minus 1 is 1 by 2, right? This becomes what? 2 by 10, right? 2 by 10, 2 to cancel, right? So you will get focus as 10 centimeter. So tell me, where will you see the you'll see the focus? You will see at here at C1. So this will be the focus of the entire configuration of the lens. Samajh mein aaya? Good to go? Right. Similarly, you were given a different type of lens like this, right? This is a plain section, okay, and this is the axis, let's say. Now let's say the R1, this is only one spherical surface, right? So R1 is, let's say, 20 centimeter, right? Now this is a plane surface, right? Remember, for plane surfaces the radius of curvature is infinity. This one has a radius of curvature infinity, and this infinity will be here, right? So let's say that is R2, that is infinity. In which direction? Suppose this is the incident ray direction, so R2 will be negative infinity. Clear? So keep that in mind. I'm removing it for guys to understand. So R1 is positive value, which is 20, because this will be the position of C1, right? And this will be the direction, right, of R1. So R1 is plus 20, R2 is negative infinity, right? And suppose this is a glass, right? So suppose the refractive index of the lens usually is what? 3 by 2. Right? Again, you are asked what to find focus. Again, substitute the values in the previous equation. 1 by f is equal to NL by NM, which is AR, minus 1 by R1, which is plus 20, minus minus 1 by infinity. Now this becomes 0, right? Then half into 20, that is, you will get focus is equal to 40 centimeter. Let's say the centimeter. So that means, where will you see the focus, guys? Here, this one is 20. So from here, from the double distance, you will see focus here, which is at a 20 centimeter from the center of curvature. Okay, clear? Now, similarly, there is a convexo-concavo mirror like this, right? Suppose the air, here it is air, and from air this is passing through the glass of the lens, and then it is, here is also air, right? Again the same like the previous one, this lens is having the refractive index as 3 by 2, and let's say the focus of this entire system is 2 centimeter. And suppose the radius of one, right, a radius of the first or any surface is double of the other radii of the spherical surface, that is any one, right? Radius of curvature of any one surface is double the radius of curvature of the other surface, that is given. Clear? This much understood, right? Now how would you how did you do this question? So this type of question you have to draw or imagine it at a larger face. I'm going to draw the lens very small, guys, because I want to enlarge it, right? So let's say this is a circle for this one, inner one, and this is a circle for the outer side, right? So this will be C1. Let's say the incident ray is like this direction, right? So the inner one, right? Right? Clear? I hope you understood, right? So the outer surface is having larger area, okay, right? So you will tell me that if this is the incident ray, so this is touching here, this is touching here, so this surface that is which is extending over here, this one should become the first surface. No, see, extension I am drawing only for you guys to understand. That doesn't exist over here, right? So obviously if I am drawing the lens separately, the incident ray is here, so it is touching this surface, so this surface becomes the first surface. So its radius of curvature R1 is supposed to be taken as R1, right? Clear? Now this one, right? So let's say that is its C1, right? Clear? Similarly, in the same line, this one center, let's say, let's make it as large. It would be better if it has been large, now let's make this one as larger one, then you will understand better. Let's make this one as very large, right? So this becomes the C2, right? The center of this bigger circle, that is for this surface. Clear? Right? Now always distance is from here, so this is R1, sorry, from here now, from this O, right? And this is R2. Clear? So I can say this is the incident ray direction, so R1 and R2 both are what? Negative. Keep that in mind. So R1 is negative, R2 is negative. This much clear? Oh, right? Now let us say R1 is R, then R2 will be double of it because it is of a larger circle, right? So its radius will be larger. So I will say, and you are given in the question that one radius is double of the other, so I'm supposed to take R2 as minus 2R, right? So NL, let's say you are given 3 by 2, right? It is 1.5, right? And see, you are given focus as 2 centimeter, right? Clear? And it is a convexo-concavo mirror, right? So you can understand it is going to be what? Diverging in nature. Okay, keep that in mind, right? And this the diversion will be happening, so because it is a convexo-concavo mirror. Convexo-concavo mirror has a nature of diverging in nature, so the focus will be negative value, right? And the focus is given as how much? I now it has been changed. I told you it is no 2 now, it is 24 centimeter. Okay, I'm sorry, it is minus 24 centimeter. Clear? Now write the value as the previous things. F1 by F becomes what? Minus 1 by 24. So here in place of 1 by F, I am going to write this minus, this will be larger, minus 1 by 24 is equal to 1.5 by 1, right? NL by NM in air, then 1 by minus R1, right? So it is minus R, minus 1 by R2, that is minus 2R. Now it is a pure calculation. Do it by yourself, guys. So you will get R's value as 6 centimeter. Right? That is the radii of the lenses. Clear? समझ में आया? Right? That is combined radius of curvature of this lens. Okay. Now, suppose here in this entire scenario we only learned when that the lens is kept in air. Now suppose the lens is not kept in air but in some other medium, right? And that medium is having a refractive index which is greater than lens, right? In that condition, if that type of condition is happening, that is, this is the lens, right? It is kept, suppose this lens is having refractive index, suppose 3 by 2, that is 1.5. And let's say this in the medium which is having refractive index 2, means if this is, right, the lens will act as an opposite nature. Clear? That is, whatever nature it was having, it will be opposite. That is, if it is a convex mirror, it will act as a concave mirror, right? Convex changes to concave and concave changes to convex. Keep that in mind. Okay. I hope you understood that theory part. Now suppose we'll do a question related to that. Okay, the question is, black came up. Right, this is a convex lens. Listen to the question, write the question like this. A convex lens is having a refractive index as 3 by 2, right? And is having a focal length, let's say 20 centimeter in air. This is in air, right? This is focus and this is refractive index, right? NL. Right? Now, the lens is immersed in a fluid, right? It is fluid. Now this scenario is changed and the air has been changed to what? Fluid, right? So that its fluid is having refractive index of how much? Let's say 20, right? You are asked what will the new focal length and the nature of the lens in this fluid. The nature will be, obviously, it will be becoming concave mirror, but we are going to show that it is true or not. Okay, so you are asked what is the new focal length. Okay, samajh mein aaya? So move on. Write the parameters, I hope. So in air, we'll first consider air conditions, right? Not air, that condition, but okay. In air, we know this lens was actually what? Convex lens, right? And I told you in convex lens, the focus is always positive. So 20 is written as plus 20 centimeter. Now we are given the refractive index of lens is how much? 3 by 2 or 1.5. And we know the medium is air, hence the medium will be having refractive index of 1. Right, just write the lens makers formula. Then 1 by F, that becomes 1 by 20 is equal to NL by NM, that is 3 by 2 by 1 minus 1, right? And there is 1 by R1 minus 1 by R2. I have no idea about the radius of curvature of the two surfaces of the lens, so I will leave it like that, right? Now this 1 by 20, 3 by 2 minus 1 becomes 1 by 2, right? That is 1 by R1 minus 1 by R2, or I can write 1 by R1 minus 1 by R2 as how much? 1 by 10. Keep this, we require this one, right? Now we are going to change, right? The air conditions we have written. Now we have changed the condition to what? Fluid. Now we are going to keep the lens in the fluid. We have no idea about focus. But lens is having its own refractive index, right? So that is 3 by 2. That is not going to change. That is not going to depend on where you are going to keep the lens. Lens refractive index is its own property, right? Similarly, now the medium, right? And radians, let's say I told refractive index 20. Let's make it a small. 20 means it is never going to end. Say refractive index of the medium is 2. Okay, let's make it a smaller. Yeah, okay, 20 means the denominator becomes large. Anyways, so what will the lens maker's formula? 1 by f. Here NL by NM, that is 3 by 2 divided by 2 minus 1 by R1 minus 1 by R2. Right, the length, I told you lens parameters is never going to change, it is fixed, right? So it's radius of curvature of one surface and radius of curvature of the other surface is not going to change. So 3 by 2 by 2 is 3 by 4 minus 1 is what? If 3 by 4 is going on, so there will be minus 1 by 4, right? 1 by R1 minus 1 by R2, which I have already found it as 1 by 10, that is the focus. So I can write actually focus value or focal length value is minus 40 centimeter. So focus is negative means we know it is a diverging lens, or it has acting as what? Concave lens, right? So initially it was a convex lens in the air. Now in the medium with a higher refractive index of 2, it became a concave lens, right? So there is a what characteristic reversal depending upon the medium. Clear, right? Right, that's why you are asked no, during rain, when you suppose the person is using a power lens, right? So sometimes you are when you are not sometimes when you pass through, or when water droplets will falls on the your glasses, it is very difficult to see, right? Clear? So it changes the focal length, right? I hope you understood, right? Now similarly, let's move on to the next smaller question. No, because I want to make you guys to understand another concept, right? Right. Suppose you are given a lens like this, and this is on the principal axis like this, right? This is the optic center, right? This is the object. Let's say it is 20 centimeter away from the from the what optical center. Now let's say the focal is given as 10 plus, right? Obviously it is a convex mirror, right? So obviously focal will be plus 10. Now let's say u in this direction, right? Let's say the incident ray is coming from here, right? So measurement is taken in the opposite direction, so u will be minus 20 centimeter, right? So 1 by f is equal to 1 by v minus 1 by v. This is for thin lens, guys, keep that in mind, right? So 1 by f is 1 by 10 is equal to 1 by v plus, right? Minus or minus becomes plus, so 1 by 20. So 1 by v is equal to 1 by 10 minus 1 by 20, or you get it as 1 by 20, or v is equal to 20 centimeter. So tell me, where will you see the image? You will see the image here. Clear? Right? One will be like this, passing and meeting here. The other, which is passing through the optic center, meets here. The image is formed here. Okay? Simple? Right. Right. So here rays are actually meeting. Right? So the image which you here get is a real image. Right? So for all the cases you cannot draw now. So there is a small pointer for you guys. When the rays are meeting, right, if you are given, or you just see the values, right? Here you see u is having negative value and v is having positive value. So when v and u are having opposite sign, the image which is formed is always real image. Okay, so when v and u are having opposite symbols, right, so the value which you get is what? A real image, or the image you get is a real image. Now in the same question you can even be asked what magnification. What is magnification's equation? M is equal to v by u. Here v is what? How much is the value? 20 centimeter, right? And what is u? It is minus 20 centimeter. So you will get magnification as minus value, right? That is, suppose I am adding something in this question. Suppose if this was not a point object, let's say the object is having a size of 2 centimeter. So the, let's say, magnification is hi by ho, that is image height by object height, that we have what it as what sorry, object distance, I don't know, sorry, image height, I don't know why I'm rumbling a lot, I don't know image height, right? So I will write it as hi itself. I just told you 2 centimeters is the height of the object, let's write it as 2 centimeter, and we just found the magnification as -1. So what is the image height? It will be -2 centimeter, right? So here, right, if this was the condition, the image would have been like this. Okay, this is how the magnification values helps you out in solving problems. Okay.